Today we are going to evaluate this limit h approaches 0 of 32 plus h, and we are taking fifth root of this term, minus 2 over h. So firstly we will try putting this h equal to 0 in this expression, whether we can get a value or not. So if we put h is equal to 0 in the numerator, we get 32 plus h. So 32 plus 0, and 32 plus 0 is simply 32, and we are taking fifth root of this. So fifth root basically can be written as 1 by 5 in the power form. So 32 raised to power 1 by 5 is equal to, we can write 32 as 2 raised to power 5, and by using law of power, the power inside and the power outside, they get multiplied. So 5 multiplied by 1 over 5 is just 1, so we are left with 2. So we get 2 minus 2 in the numerator, and which is 0, and we get 0 in the denominator. So this is basically 0 by 0 form, which is indeterminate form. It is not equal to any value, so we need to get rid of this in order to evaluate this limit. And we can see 32 in our first term. So what we can do is write this 2 in the numerator as in the form of 32 as well. So if we write 2, we can write 2 as 32 raised to power 1 by 5. And I have written the radical form in power form of the first term as well. So I have written 32 plus h raised to power 1 by 5 minus 32 raised to power 1 by 5 over h. And if you look closely, this whole limit, this kind of resembles with the definition of derivative. So if I've written the definition of derivative here, it is simply f dash of x is equal to limit h approaches 0 f of x plus h minus f of x over h. So both of the limits are approaching, in both of the limits h is approaching 0. This is same. In both of the limits we have the same denominator h, and in the numerator, in the definition of derivative, you have a function, and that function is taking two separate or two different inputs. Firstly, it is taking x plus h as input, and secondly, it is taking x as input. So this means that in the numerator, a function is being used. The function is same, just taking two different inputs. And what does a function do? It applies some sort of operation on the input, and it gives an output. So if we compare this definition to our required limit uh, in the numerator, it involves two terms just like this. It involves two inputs just like this. Here the input is 32 plus h, and here the input is 32, and both of the times same operation is being applied, that is taking the fifth root of the input. So this is very similar to this limit. The only thing different here is that in place of x we have written 32. So this is the only thing. So this is not f dash of x, it is f dash of x is 32 here in both terms. So this is f dash of 32. So this was our definition of our derivative. It is f dash of x, and here the x was 32. So this is f dash of 32. So our required limit is just f dash of 32. So we need to find the value of the derivative at x is equal to 32. So firstly, we can see that the function here is x raised to power 1 by 5. We are just taking the fifth root of the input. No matter what the input is, if the input is 32 plus h, we are taking the fifth root. If the input is 32, we are also taking the fifth root of that input. So the function is f of x is simply x raised to power 1 by 5. So we have found the function f of x. We just need to take the derivative of it because our required limit involves derivative. And after taking the derivative of f of x, we'll just put x is equal to 32 in that. So I've written here that by comparison, our function is f of x is equal to x raised to power 1 by 5 and x is equal to 32, simply by comparing the required limit and the definition of derivative. So we need to find f dash of 32 to find the required limit, and for that we need to find f dash of x first, and f dash of x is simply f of x is x raised to power 1 by 5, and f dash of x can be simply found by taking derivative of this x raised to power 1 by 5, and we can apply power rule of derivatives to find the derivative. And what power rule does is simply it puts the power in front of the variable and we subtract 1 from the power. So 1 by 5 will go in front. This will become 1 by 5 x raised to power 1 by 5 minus 1. So the power has come in front and we have subtracted 1 from the power. So 1 by 5 into x raised to power 1 by 5 minus 1, and in power we can take LCM. So 1 by 5 minus 1 becomes 1 minus 5 over 5, and 1 minus 5 is simply minus 4. So we get minus 4 over 5 in the power. So this is basically the derivative of our function, and our limit was simply putting x is equal to 32 in this f dash of x. So we'll just put x is equal to 32 in this. And when we do that, when we put x is equal to 32 in this derivative, we get 1 by 5 times 32 raised to power minus 4 by 5. 32 can be written as 2 raised to power 5, and power of law of power over power will be used and powers will be multiplied. So this will become 2 raised to power 5 into minus 4 over 5. 5 and 5 will be cancelled, and we'll be left with 1 by 5 into 2 raised to power minus 4. So if we want this minus 4 to be positive, if we want 2 to have a positive power, we need to move this to the denominator. So 1 by 5 into 1 over 2 raised to power 4. So this is 1 by 5 into 1 over 2 raised to power 4 is simply 16. So 1 by 5 into 1 by 16, which is 1 over 80, and this is our required limit.